Hello, my name is Ali Mirzan bin Muhammad Zain, and today I will make a final presentation about my project, which is a face verification using Siamese network. I will explain about a complete system pipeline, metric interpretation, final result, and a facilities engineering deployment consideration. Okay, next. So, for the complete system pipeline, we start with a data preparation, where the raw images are organized into the folder by a person. Each image is resized to 100 by 100 pixel, normalized and paired into a positive and negative example. Next is the embedding model. The convolutional layer extracts the facial feature and the dense layer compress them into a 128 dimensional vector representation. So this is the embedding model that I get. Next, the embedding model are fed into the Siamese network. This is used two identical model to process the image pair. A Euclidean distance layer then compute how similar the two embedding are. So this is my Siamese network of table. Okay, next. Next, we go to training. During a training, we use constructive loss to optimize the embedding. The model is trained for the 10 epochs with a batch size of 8, and the validation split to ensure it generalizes very well. Next is the evaluation stage. We predict the distance for the test pair and tune the threshold to maximize the accuracy. Next step is the verification. The verification function run in a real time, outputting either the same person or different person, and even the visualize the comparison with a side-by-side image. And lastly, we will train the model is a safe in a class format and ready to be integrated into the application such as facility access control system. Next. So for the metric interpolation, firstly, the confusion matrix show the perfect classification. Every same pair and a different pair was correctly identified. There were no false positive and no false negative. At the chosen threshold of 0.20, the model also achieved the 100% accuracy, which means it separates the class flawlessly on the test set. The ROC curve also reached the top left corner, which visually confirms the ideal performance. For the AUC value, we get is a 1.0, which indicate the model are perfectly distinguished between the genuine and exporter pair. At this threshold, both FAR, which is false accept rate, and FRR, which is false reject rate, are both zero point zero. So the system either accept unauthorized user or reject the authorized one. And finally, the equal error rate, which is EER, is zero point zero at a threshold of about negative 0.19, showing that there is no trade-off between the FAR and FRR in this dataset. For the final result, the graph shows the both training and validation loss decrease steadily. It shows the effective learning. By the last epoch, the loss converged near zero, this proving the model has been stabilized. The validation curve matches the training curve, which means there is no overfitting. Overall, the graph is strong evidence of a stable and a reliable performance. Now, we look to the verification result. The system calculates a distance of 0.0959 between the two images. Our base threshold is a 0.20, which acts as a decision boundary. Because of 0.0959 is below 0.20, the system corrects the output as a sample set. This example proves the threshold ensures the secure, accurate verification that consistent with the 100% accuracy that achieved. For this slide, I will talk about a facilities engineering deployment consideration. First is computational cost. Running a Siamese network requires a GPU or high-performance CPU research. For industrial deployment, it may need a lightweight model or each device to reduce the cost and make the system more practical. Next is a real-time feasibility. The system processes the verification in a millisecond, which makes it suitable for the real-time access control at a facility, door, or checkpoint without causing a delay for employee. The third one is a security risk. We must consider both type of error, which is a false accept (FAR), that means an unauthorized person gain access, which is a high security risk. Next is also a false reject (FRR), which means an authorized employee is denied entry, which cause the operational inconvenience. Balancing the FAR and FRR is critical to ensure the board safety and usability. The number four is scalability to the large number of employees. In a real facilities, the system must handle 100 or even thousand of employees. This requires efficient database management, embedding storage, and a fast retrieval to keep the performance consistent. And lastly, we had a hardware requirement. The deployment depends on having a right hardware, camera with a good resolution, reliable server or each device, and securing networking infrastructure. These are essential for operating in hazardous or sensitive environment. So that's all from me. Thank you.